Okay, so thank you for joining this webinar about mesh-free liquid flow simulation by couple Romax Energy with Particleworks. So before starting, we are very sorry for this technical issue with the webinar application. So yeah, we are very sorry for that. So I am here with Rob Hallhouse from project, who is a project manager at Hexagon. So me, I am DJ Zefrak from Powersys. So I am multi-physics engineer on different software. So the agenda of the webinar is below. So in the first part, I will present Powersys company. So I will also introduce the moving particle simulation that is implemented into Particleworks. Then into the second part, Mr. Rob will present the Hexagon company, and he will also introduce you the Romax Energy tool that we use to couple with Particleworks, and he will also do a live demo on the coupling between Romax and Particleworks. In the next step, in the next part, so the part 3, so I will then show you the demo on Particleworks, how the model that Rob export from Romax can be easily run and can be easily run it into Particleworks in order to check the oil flow distribution. Yeah. Then I will also present some study cases and present some advantage feature of Particleworks. And at the end, we will do some conclusion, and we will try to reply to your different question. Okay. Then let's go to the first part. Yeah. So, so Powersys, it is consulting. So it is engineering and consulting company. So which provide different solution. So it provide different solution in different application field. So the first application field is the power electronic tool. So we have different tool from smart to T-form. So you can use that to simulate any type of electric circuit. And then the second field is the multi-physics system level simulation by using Saber for also circuit, and also Flownex is the 1D fluid mechanic simulation by using some component. And the next application field is the CFD. So by using Particleworks and Cardell. So for this webinar, we will show you how to use Particleworks to make a multi-physics using with Romax. Okay. So at the center of this different application field, we have JMEC. So JMEC, it is finite element tool dedicated to the development and simulation of any type of electrical motors. So the global objective of Powersys is to provide you a good simulation platform that you can use to electrify your system. So related to this product, so we provide also different services. So we provide support, we provide training. We also do some strategy for our different customer, different company. So we can also customize some services. We can do automation. We can provide some HPC cloud for hardware for very complex simulation. We can also provide some script that you can help you to make some operation into our product. Okay. So in the world, we are located in different areas. So in France, at the headquarters is based in France from Aix-en-Provence. We also have some office at Paris, also in France, Frankfurt, on the other side of the world. So here you can see today, so we have more than 2,000 of customers, and today we have more than 50 employees which work on at Powersys. Okay. So we have different customers, so I will not spend time here, but we have a lot of customers which use our tool. Okay, so as introduction regarding Particleworks, so the goal of this part is to show you the MPS method. So MPS stands for mobile particle simulation, that is embedded into Particleworks. So the mesh is needed, and it is very easy to use this tool for fast simulation. We also present the other field, the application field of Particleworks is for example, the lubrication, which is the goal of this webinar. I will also introduce the e-motor coding. So this part is also important. So we can use Romax and Particleworks to simulate, to make a multiphysics using electric motors. And at the end, I will show some advanced feature of Particleworks. Okay. So what is Particleworks? So Particleworks, it is a meshless free simulation tool that allow you to discretize any fluid by a set of particle. So here you see that the mesh is not needed, so the fluid will be discretized by the particle, and it is very easy to set up this kind of complex gearbox and in at least 1 day. Yeah. So Particleworks is suitable for face-to-face flow and also liquid jet simulation. So into the right side, you can also use Particleworks to simulate or to couple a rigid body with fluid, with any type of fluid. So we can use liquid and also powder. Okay, so Particleworks, as I said, so Particleworks is, yes, it's not using the mesh, so it uses the particle to disguise the fluid. Yes, and if we look the conventional CFD tool, where we use finite difference or finite volume method. So here we see that the fluid volume will be disguised by using some fixed grid here, and the pressure and velocity will be calculated on the node of the grid. Yeah. So this is for conventional. But now in the Particleworks, we use the MPS method, where the fluid will be discretized by a particle, and this particle, and inside this particle, on this particle, we make the calculation in order to calculate the velocity and the velocity and any pressure HTC, and this particle will follow the oil flow. Yeah, and here we use the Lagrangian approach to solve the Navier-Stokes equation here. And with this MPS tool, is very fast and easy to simulate any type of application. So this method was originally proposed by Professor Koshizuki at the University of Tokyo, which is the co-founder of Romax software since 86. Okay. So if we look the different steps to create CFD or to run CFD model, so into the standard or conventional CFD tool, we need to prepare a card, generate the mesh, define some condition, and run the simulation. Yeah, and this takes generally this conventional method take a very long time. That now with Particleworks based on the MPS method, so it's no need to generate the mesh. Directly we import the card, we define the condition here, and we run the simulation, and we can get in few hours the result. So it is very simple to move any machine into Particleworks in few hours. So regarding the different applications, so the main application is oil pressure and lubrication on the gear and transmission system. We also have lubrication on engine. We have piston cooling or motors cooling. So even if there is some channel, so Particleworks are able to simulate the oil flow inside the rotor or starter channel. So we can also simulate. We can also run the simulation by using a fluid with higher viscosity. So we can simulate, for example, the flow of the glue, cement, grease, and so on. Okay. So the other application is the bearing. So the lubrication of the bearing. So here we can see how the grease is flow inside the bearing. We can also simulate the offer water flow into the turbine. Yeah. And for civil engineering, we can perform some water management by simulating weeding or rain or snow cooling. Okay. So regarding the coupling between Romax and Particleworks, the process is very simple. We start by creating the Romax model, and from the Romax interface, we use the export save the tool to export the Particleworks model that is ready to open and run from the Particleworks software. So this is the easy and the fast way to make the multi-phase coupling between by using Romax Energy and Particleworks. Okay, so this is for the first part. Then we will switch to the next part, which will be presented by Rob. So okay, so Rob, I will stop sharing. So I will make you presentator. Yeah.
Okay, can you confirm when you can see and hear me?
Yes.
Or, yep. Okay, perfect. Thank you, Didier. So good morning, everyone. Thanks for joining this webinar. My name is Dr. Rob Holhouse. I'm product manager at Hexagon for Romax Evolve and Romax Energy. So at Hexagon, data is at the center of everything we do. We believe that data holds the key to working smarter and more sustainably across all industries and all human activity. But we also see data as an underutilized resource, often captured and stored, but not always analyzed and used to its potential. That's why our vision is to fully and autonomously leverage data so that business, industry, and humanity sustainably thrive. In order to make this vision a reality, we want to enable better use of data across the industries we serve and to create value for our customers in doing so. Hence our mission, putting data to work to enable autonomous, connected ecosystems that boost efficiency, productivity, and quality for our customers. Across the Hexagon organization, there's a number of divisions covering everything from agriculture, geosystems, mining, safety, infrastructure, and others. I'm part of the manufacturing intelligence division, and within that division, we have sections on metrology and inspection, production, and design and engineering software. Within design and engineering, we have a number of centers of excellence, covering a wide range of simulation software capabilities, autonomous solutions, thermal cooling, acoustics, structures, manufacturing, materials, and I sit within the System Dynamics, COE, under which we have two world-renowned products, Romax and Adams. Now, focusing in on the System Dynamics COE, we have very long, well-proven track record in simulating machinery. I won't read through this whole slide, but we have years of experience in renewable energy, in wind turbines, in automotive applications. 70% of cars being produced now have employed our software in some way. Many mass production vehicles use our software, but also a few more specialist capabilities, including F1 teams. So very strong track record in drivetrain simulation. Within the Romax software suite, we have 6 main products targeting a range of user requirements. We have Romax Concept for early evaluation of drivetrain concepts, Romax Evolve, a tool specifically for analysis of electrical machines, Romax Enduro for durability analysis, Romax Spectrum for system level NVH analysis, Romax Spin for world's leading capabilities for bearing simulation, and Romax Energy, our tool for efficiency calculation of drivetrains and transmissions. And it's this last product that we're going to be talking about today. So, key functionality in Romax Energy. Romax Energy has been set up to meet challenges facing the industry today. Challenges like higher efficiency targets, tougher emission targets, electric vehicle energy consumption targets, and shorter development cycles. We achieve the solution by accurate and user-friendly prediction of component and system power loss early on in the design process. Key features to achieve this: easy drivetrain modeling, very intuitive 2D and 3D modeling, which means the user can get started, build Romax models of complex drivetrains very quickly. Component efficiency models to evaluate the efficiency of gears and bearings. Some of these models use published standards, ISO standards. Others use state-of-the-art methods, best-in-class capability for gear efficiency based on microgeometry, based on detailed lubricant analysis, as well as Romax's world-leading proprietary advanced bearing loss tool. Using these efficiencies, we can generate efficiency maps, energy consumption over drive cycles, and be able to manage trade-offs when linking to other Romax products, manage trade-offs between efficiency, durability, and NVH targets. And finally, through the CFD interface that we'll be talking about in a little more detail, we've got link-ups between Romax and Particleworks CFD analysis to help bring CFD earlier on in the design process. So, the link between Romax and Particleworks, why have we done it? Well, as Didier was saying, Particleworks, it's a proven and robust simulation tool, and one of its many capabilities is for gearbox lubrication problems. The SPH method is the most appropriate capability for the typical Romax Energy end user, typical problem being fluids churning within a gearbox. And by building an automated setup, we've helped to bridge the gap between Romax's analytical methods and a fast CFD analysis. We've done this to address key pain points in the industry. It's well known that early on in the design process, it's cheap and easy to solve problems when there's a lot of design space left to explore. Later on in the design process, it's not easy or cheap to make any changes. And so often we know from our customers, CFD is only done late in the design process. It takes time and it's expensive. That means that at the early stage, there's very little data on fluid distribution available to help drive design decisions. So by building these links between Romax and Particleworks, we're setting out to bring particle-based CFD early on in the design process, make it even easier for drivetrain designers bring CFD analysis into their early stage design. Now, the key value here is to further reduce the setup time needed to pre-process the model. Automatic calculation of speeds, implementing best practices based on Romax engineers' experience, Particleworks expert experience to make the CFD capability as easy as possible. And it means that for a Romax user, they can use the same model for their efficiency analysis, durability and NVH analysis, and take that same model for their CFD analysis, thereby minimizing user error. This greatly promotes a CAE-led design and helps promote a data-driven design optimization. It's all about democratizing analysis, helping non-CFD specialists conduct CFD analysis and thereby save costs, reduce the time to market. So ultimately, how does this work? So user can take a complete Romax model. This example, it's a Romax Energy drivetrain model. They need to define the MPS simulation parameters. They can accept the defaults that Romax calculates for them or define manually. Define the fluid properties. Well, these are already used in the Romax analysis for our efficiency and our durability calcs. Generate a geometry file for each component and calculate the kinematics of every component. What speed is it rotating at? What's its origin? Is it rotating about its own axis or whirling through the drivetrain? And finally, take that data and build the model fully within Particleworks. Key thing about this process, it's completely automated within Romax Energy. All the user has to do is accept a few defaults. Romax will do all of this for them and generate a ready-to-use Particleworks model. So I'll just take you through a quick demonstration of some of this capability. So here we have an example of a typical drivetrain model in Romax. We can see it's a single speed, two-stage parallel transmission. Let's include the housing, consisting of electric machine, 2 gear stages, each gear stage supported on shafts. We can view it in 3D, and when we view the housing, again, we can see the kinematics of this drivetrain with the reduction gearbox. Now, I won't include a demo of the efficiency analysis, but for a typical efficiency analysis, you just select what loss models you want to use, either ISO standards or the Romax advanced methods for bearings and gears. And from that, the user can generate a report of detailed loss calcs for every component for single operating point. Can generate an efficiency map over the full operating region, or generate a loss breakdown across a full speed range. So this is a really nice example for the sake of this webinar. We're showing that although bearing friction is quite significant, the number one loss mechanism within this drivetrain is gear drag. So that's the churning loss as the gears pass through the fluid. So that really highlights the importance of being able to get an accurate prediction of churning loss. Then to export the data from Romax Particleworks, just select Export to Particleworks, and then this simple wizard takes you through all the steps to generate the model. We can select which components to exclude from the export. So we'll hide these external mounting points because they're not needed for the CFD analysis. Check that the units are all right. Looks good. Surface tension coefficient, slip condition. Again, default's absolutely fine. MPS settings, accept the defaults. Simulation, default particle size, calculated based on the geometry of the drivetrain. Again, these defaults based on experience. And finally, select the time we want to solve the problem for. So we'll rotate it through a single rotation of the output shaft. Then all we have to do is click Refine in CAD, and that launches this CAD application. We want to make one change to the model. We want to replace the housing, which has been based on a faceted FE part, and replace that with a smooth housing design from CAD. You can see all the drivetrain internal components have been brought in. So we swap out the housing for a smoother version. There's a couple of changes to the inverter. The mounting points are different, but the geometry of the gearbox housing is absolutely fine. So this gives our final design that we need to export to Particleworks. And finally, we just have to click complete, and this will automatically generate all the components, send that data over to Particleworks through the API, and the user will have a Particleworks model ready to go, ready to use. And this is what the Particleworks model looks like that is created from the Romax model. We make the housing transparent, we can see all the components are present, and when we animate it, we can see every component rotating about its correct axis at its correct speed. So shafts, gears, the rolling elements within the bearings, all that data has been passed over automatically. We just need to define a location within the drivetrain to define where the oil fill point is. And then finally, open up the settings window, and all the defaults that Romax set are all in the model and ready to go. So then it's just a case of selecting to either run the pre-process or the full simulation and clicking execute. Obviously, I won't include it in the webinar running the execution, but it really is that simple to take a mature Romax model, 5-10 minute job to set up a fully functioning Particleworks model from that Romax model. And with that, I will now hand back to Didier.
So thank you, Rob. So let me share my screen. Okay, so let's continue with the next part, so part 3, where I will try to show you the result of the gearbox lubrication into Particleworks, and I will also present some use case and some advantage of Particleworks feature. Okay, so regarding the demonstration, Rob show you how to export the model. Then from Particleworks, they have import this model. I just run the simulation to check the oil flow distribution into the gearbox. Okay, so let me go. So let me know if you can see my screen.
Yes, I can.
Okay, good. So this is the model which comes from Romax. So here, okay. So after running the simulation, so here you will see that after the calculation, Particleworks will create some set of the fluid. So here you can see that in blue, this is the particles which represent the oil here. Then you just need to go here and then execute to run the calculation. And after that, here you will be able to see how the oil is flowing inside Particleworks. Okay, so you can then after running the calculation, you will have a lot of post-processing function that you can use. So here you have the Particleworks interface, and here you have some post-processing functions, so surface of the fluid that you can generate. You have mapping, you have a pipeline that you can export here. And on each project, so because here you have the project which come from Romax, from each project you can create several scene or several analysis, and for each scene here you can confirm. So you can confirm all the settings that Rob defined from Romax. So you have, for example, the material. So you can check the physical properties of the material that that was defined from Particleworks. So here, this means that here you have the module which is already which is ready to run. So you don't need to add some setting. Okay. So here I can also show you some, let's say you can, no? So here you can check some particle density. Here, for example, you can display the HTC. So on the HTC on the fluid. Yeah, you can also show, let's see, the HTC on the housing. So here you can check the distribution of the HTC on the housing. You can also see the surface, so the surface of the oil here. Okay. You can also let's say display the velocity of the fluid. So here I can play a little bit here. So after simulation, so Particleworks will create so the calculation folders, and inside the calculation folders, so here you will have some CSI which contain some parameters, which is very important to understand the kinematic of the gearbox. So for example, if we check is the input wheel, so here you have a lot of parameters. So for example, if I check input wheel, this one, here you have all the physical quantity that Particleworks calculate from this gear. So you have the force on different axes. You also have the torque. So you have you also have the torque. So for example, this torque can be used to calculate the power churning losses here. So you can confirm the graph. So yes, you can confirm the graph. So here, yeah, and you can also confirm. You can also plot some graph from Particleworks. Okay, let's see. Sorry, here. Let's say I will plot the torque. So here I will select the input wheel, for example. So here I will select, I want to plot the torque. So here I will select total torque. Yeah, so for example, I will check, you can check this one. Okay, then here you will have the torque, the plot of the torque. Okay, so I can open, I already made some calculation of the churning loss. So it is very easy to calculate the churning losses. So here, for example, here, I take this, I export this table from Particleworks data. So I get the torque from the Z-axis of the input wheel. I do the same with the output wheel. Okay. So So here you can confirm the graph of the top, of the oil. Then here I try to calculate the models based on the speed. So here you can compute the value of this power in kilowatt. Okay. So okay, so let's continue with another statistic. So the first statistic that I want to present is was done by common industry. So so the objective was to simulate the objective was to use Particleworks in order to simulate the coupling gearbox that you have here. So the target was to compare the measurement with Particleworks result, and by running the simulation with different operating points or different speed. So the simulation was done and also the measurement was done. Then the industry was very happy in the fact that the measurement matched well with the simulation here at the different operating point. So here, so Particleworks is very efficient to handle the oil flow into the gearbox. Okay. So the another case is from a different driveline. So the objective was model the oil distribution into the vehicle gearbox by using Particleworks. So here you have the link. If you want to find the paper about that, you can use this link to access the paper. Okay. So the simulation was done quite easily with the Particleworks. So they can have confirmed the oil distribution inside the gearboxes, and they have also made the comparison between the measurement and the Particleworks result. So and the result match very well. Okay. The last one regarding the lubrication is was done by GEMA. So GEMA is the constructor of gearbox for tractor. So the objective was to also simulate and calculate evaluate the oil jet efficiency by using Particleworks. Yeah. So they use some specific oil property, and they want to confirm the distribution of the oil inside this gearbox. Yeah. Okay. So also Gina was very happy because the target was achieved. So they have made a couple of simulation by using different geometry of oil jet. So they are also able to improve the different times. So they find the best way or the right geometry and that amount of the oil. So and from Particleworks is also very easy for us to visualize the oil distribution and to compare it with the measurement. So here, so the one of the target is and that they also want to confirm if the oil is well distributed around the gear. So here they are well confirmed that with the Particleworks. Okay. So another application that we can also model with Particleworks, so is electric motors. So with Particleworks, so Here, for example, we have a Hexagon company, so one developer of a system for the cooling of electric motors. So the target was to run the simulation, so the cooling of the end winding by using Particleworks, and compare the simulation. So compare the Particleworks simulation with the measurement. Yeah. So generally, we see that at the end winding, generally the loss is very higher. So and the use of the air is not enough. So this is why Ricardo want to use Particleworks in order to simulate the oil cooling of the end winding and compare it with the measurement. Okay. So during this project, so here they use Particleworks in order to simulate the oil flow and extract the HTC coefficient distribution based on the oil distribution. And this HTC can be used into thermal analysis for temperature calculation. So here you can use GEMEX. So GEMEX, it is finite element simulation tool that allow you to design and simulate any type of electrical machine. So from GEMEX, you can create thermal analysis, import the HTC distribution map, and then run the thermal analysis to confirm the distribution of the temperature of the end winding. Yeah. So many point was done into Particleworks. So we also able to check the windage effect. So because the rotor is rotate, then it will generate some air field around the end winding, and this kind of effect can be taken into account during oil flow simulation with Particleworks. And we can also confirm the accumulation of the oil around the end winding. So as you can see here, so from the oil distribution and accumulation, we can extract the HTC that we can import into the thermal analysis to calculate the temperature. Yeah. So at the end, Ricardo was very happy because the target was achieved. So they compare the Particleworks result and the measurement result. They see that the max difference was around 5 degrees. So they was very happy for this project. If you want to follow the paper, so here you can scan this QR code so to access the paper about this project. Okay. So regarding the advantage of Particleworks feature, so I will try to present some advantage. So the first one is how to couple the fluid volume analysis with the Particleworks. We also show some advantage because we can use Particleworks for fluid and fluid interaction simulation, and even if the motion of the solid is very complex, so we can make some 6 degrees of freedom analysis. Yeah. We can also use a Python. We can build a Python script in order to make some automation, in order to make some automation process operation into Particleworks. From Particleworks, it is also possible to create some realistic video. So from this means that from the result video that you will create from Particleworks, it is possible to generate some realistic video from marketing purpose. So regarding the first advantage, so here we can see that in this model, so we have coupled Particleworks with some finite volume method analysis, where around the bottle we have the air, and the air is meshed, was meshed by the grid. The water was meshed by the Particleworks by using the particle, and where you can see the interaction between the water and the air. So you can see the air is we enter the water, and the water will go out of the water. You can confirm the pressure on the air. Yeah. Okay. So regarding the fluid interaction simulation by using the 6 degrees of freedom analysis. For example, here this is the turbine, and yes, it is possible. It is possible to make this kind of simulation into particles, where we will try to use the particle in order to discretize the solid here, and we will try to run the simulation in order to see how the fluid is pushed up is making the turbine to rotate. Regarding the Python script, so you will have the possibility to use some Python module dedicated to Particleworks in order to create some script to automatically define some setting, to create some to add some function, and automatically you will be able to run some simulation from Particleworks. And yes, you also have some function for processing in order to, for example, calculate the torque, create some screenshot or generate some videos. So you create a script, and in few seconds you will obtain what you want. Okay. And yes, from Particleworks video, yes, it is possible to export some video, and then you'll be able to use Blender to make some realistic videos. So here's from, yeah. So you can make this kind of video for marketing purpose. Okay, so this is for the part 3. Then we can switch to the last part, so the part 4 for the conclusion. And so I will switch to Rob. Okay.
Okay, can you confirm you can see and hear me again?
Yes, I can see the conclusion remark. I can see your slide.
Okay, perfect. Thank you. So just a couple of things to conclude on. Firstly, the case study we've shown was based on a fairly simple drivetrain topology, single speed gearbox, 2 parallel shafts rotating about their own axis. Of course, there's a lot more complex drivetrain topologies out there, and calculating kinematics is not always quite so simple. For example, multi-speed transmissions, such as found in a manual vehicle, have a lot of different shaft rotational speeds. Planetary gear sets, where gears orbit around a common axis rather than rotating about their own axis. So there's a lot of different speeds and coordinate systems that have to be defined. Typical use of planetary gear set is wind turbine gearbox, or automotive automatic transmission, or differential internal parts, where the differential gears are orbiting about a different axis to the one they're rotating about. So lots of different complex topologies out there, and the interface between Romax and Particleworks is capable of making sure that all of these topologies correctly calculate the kinematics, and again, make sure that data is correctly passed to Particleworks. So for very complex topologies like this, can have quite significant time saving in making sure the model is correctly set up. To conclude, the Romax software suite from Hexagon is a complete set of tools for CA-led design of drivetrains. Amongst a wide range of capabilities, I've been talking about Romax Energy, uses standards-based and best-in-class proprietary methods to calculate efficiency. Particleworks is a meshless CFD approach, able to provide very quick design indications within less than a week. And the export from Romax to Particleworks is a quick and intuitive way to pass drivetrain geometry properties and kinematics into CFD analysis. By simplifying the model setup time, Romax Energy can help bring CFD analysis earlier on in the design process. Ensured any potential problems are identified earlier on in the development cycle. Okay, so that concludes what we have to share for you today. For more information, please do get in touch with either of us. Contact Didier for any information about Particleworks, or for any information about Romax Energy or any of the Romax capabilities. Do contact myself. Our web addresses and contact details are on the screen now. Or if you'd like to learn more about the interface, please contact both of us. So I think that concludes what we have. One common question that's crops up a lot in the Q&A session: will there be a recording released of this webinar? Yep, absolutely.
Yeah. So yes, after this session, we will try to put the recording on the website, so you'll be able to follow this webinar from the website. Okay, so any question? So for any question, you can type it on the chat box. So okay, so there's no question, so I think we can end the webinar, Rob. So thank you for the attendee to join this webinar. I'm sorry for the technical issue that we got this morning. Yeah. So for any question, as Rob said, so feel free to send us some email. Feel free to send your question from email. Yeah. So thank you, and so, I have some. It's not question. Sorry, my chat doesn't work. Doesn't work. Thing for the question. Yeah. So thank you also. Okay. So thank you, and bye.
Right. Thank you. Goodbye.
Yeah, thank you. Yeah. Bye.